Bismillahirrahmanirrahim. The analysis of variance or ANOVA. This method is used to testing for difference between several sample means. Testing for a significant difference between several sample means is done by F-test, which may be surprising at first sight. How can a test which compares variances be used to compare means? The justification runs as follows. It can be shown that the means of samples, each of n items from a single normal population of variances are themselves normally distributed with variance sigma tau divided by n. At the first, I am going to describe for testing difference of means between several sample of the sample size. That is one-way ANOVA. If we have M treatment and we take n observation for each treatment, the results can be shown as following table. Treatment one, treatment 2, treatment 3, and treatment number M. And here is observation number. Observation 1, 2, and observation N. Observation 1 in treatment 1 is x11. Observation 1 in treatment 2 called x21 and so on. xm1. In observation number 2 and treatment 1 is called x12, x22, x32, and xm2. And finally, observation number 1 in treatment 1 is x1n and x2n, x3n, and xmn. With summation of this column and row, we can calculate the total and mean of column and row, and finally grand mean. I fill in this table. Total is sigma x1 for column 1, sigma x2 for column 2, sigma x3 and sigma xm. The mean of any column is x bar 1, x bar 2, x bar 3 and x bar m. And the grand mean is total x bar, that is sigma x bar I from 1 to m divided by m. Excuse me. Two variances are calculated as follows. One, the observed variance of the treatment means about the grand mean, that called between means variance, calculated by this formula. S between, that is variance, no standard deviation, is equal minus x bar, finally x bar m minus x bar m minus 1. This is between means variance. If the null hypothesis is true, if H0 is true, SB2 is an estimate for sigma 2 per n. The average of a standard deviation of population. With m minus 1 degree of freedom. Since the standard error of the treatment means is sigma over radical n. Therefore, NSB2 is an estimate of sigma 2 with m minus 1 degree of freedom. If H0, the null hypothesis, is true, that is, this means the M set of results come from the same population. The observed variance within a single set is also an estimate of sigma 2 with n minus 1 degree of freedom. We can average these estimates of sigma 2 from M treatment to get an estimate of sigma 2, which is the within means variances. SW2 within means of variance. That is as follow. SW2 is equal x11 minus x bar 1 plus x12 minus x bar 2 xmn minus x bar m multiplied by m divided by m multiplied by m n minus 1 degree of freedom of within means variance is m multiplied by n minus 1. We calculate f as a ratio of these two variances. F is equal n SB2 SW2 with m minus 1 degree of freedom for between means of freedom and with m multiplied by n minus 1 degree of freedom for within means variance. NSP2 represents the variation in results due to the various treatments having different effects. SW2 represent the experimental error. Various treatment having different effects. This is an example Suppose we have an original composition 1 and 3 modification of it. 1 is the original composition of a cement, and 2, 3 and 4 are 3 modification of the cement mix. And for measurement, for example, for measurements of 24 hours, strength are made on each product. Treatment treatment 1, original composition of cement, mix composition, and mix composition. Observation number number 1, number 2, number 3, and number 4. For observation of any treatment listed in this table, for treatment 1, the one observation is 96, 2 is and 3 and 4. These data are the strength of the product. Observation number 2 for treatment 1 is treatment 2, treatment 3, and treatment 4, and here observation number 4 for any treatment is this data. We can calculate the mean of any treatment here. For original cement, x bar 1 is equal, and this is for x bar 2, x bar 3, and x bar 4. And the ground means is 1 over 1, 2, 3, 4 sigma xi, that is this number, total mean or grand mean. We have to find whether there is a difference between a mixed cement with original cement in its response. Here M is equal N equal 4. M is number of treatment, that is 4 treatment, and N is the number of observation of any treatment, that is 4 observation for any treatment. And therefore SBA2 we can calculate as this formula is 105, and SW2 within sum of square can calculated by its formula is 10.33, and with F test is the greater number of sum of square divided by this is 10.60. This is one-tailed, and because we have to compare any mixed cement with the original cement, that is greater than or not. Therefore, this is one-tailed test, And from table F, with degree of freedom 3 and 12, 3 is n minus 1, degree of freedom is n minus 1, 4 minus 1 is 3, and 12 here, degree of freedom of total treatment is m, that is 4, multiplied by 4 minus 1 is 12. From table F with this degree of freedom, at alpha 0.01 and alpha 0.1, this is for 19% confidence and 99% confidence. The number of F from this table is 5.95, and for this confidence is 10.8. This number of F is between these two confidence limits. Therefore, it is over 99% and this is over 19%. There is highly a significant difference between, because this number is very close of 99%. Therefore, we can conclude that there is highly significant difference between the means. We can now test the modified process means against original process mean and against each other by t-test to seek which modified process is better, because there is a highly significant difference between them. If the F-test proves not significant, we can be sure that there will not be a significant difference between any pairs. Therefore, the modified cement is not better than the original cement. In another case, we may wish to obtain results from M analysts, each using n different analytical method. The analytical method is different. The results are now divided into two criteria. with two set of means because analyst mean is different and the methods are different. And we have a two-way analysis of variance. Two-way analysis of variance because the method are different and the analysts are different. It called for the analysis of this variance we should use two-way analysis of variance. If each analyst does each method only once, there are m multiplied by n observation. The total variance is divided into a between analysts variance and between methods variance and an error variance. The error variance becomes the denominator of f, and we can analyze for significant effect due to analyst and due to method. The results layout for two-way ANOVA and replicated experiment is shown in this table. Treatment block. Treatment number 1, 2, 3 and M. Here is row sum. For example, for analyst and the block in method of analyst is 1, 2 and n. And here is column sum. The n method. x1 1, x2 1, x3 1, xm1. The row, for example, is b1, block 1. 2, x1 2, x2 2, x3 2 and xm2. The sum is b2 and x1 n, x2 n, x3 n, xmn and bn. and the total column sum may be demonstrated by C1, column 2, sum of column 2, sum of column 3, column M, and finally T is the sum of this column or sum of this block row. T is the summation of 1 till MC, or is the summation of 1 to N by block. Grand mean is T divided by Mn, and the correction terms is T2 divided by M multiplied by N. Here is the table of ANOVA. Source of variance, sum of squares, degree of freedom, and mean square. The source of variance for between treatment. For example, in this example, the error between analysts, and another source of variation is between block. The error between the methods of analysis, and here is residual. And finally, total. The sum of squares can be calculated by this formula. Sigma C2, C is here. Minus T2 over to Mn, and the degree of freedom for this is M minus 1, and for calculate the sum of square of between block you can use this formula, sigma B2 per M minus T2 Mn, with N minus 1 degree of freedom, and for residual you can calculate by this formula. If this is formula 1 and this is formula 2, the total is sigma x2 minus T2 per mn. For residual, you can subtract it 3 minus 2 minus 1 with m minus 1 multiplied by n minus 1 degree of freedom, and degree of freedom of total is mn minus 1. Total of experiment minus 1 is degree of freedom of total. And mean square is sum of square divided by m minus 1 is this mean sum of square of between treatment. This is SS, sum of square. And for calculate this mean sum of square of between block, you can do from this formula SS sum of square divided by degree of freedom n minus 1. And for residual, you can calculate from this formula sum of square divided by degree of freedom of residual n minus 1 multiplied by n minus 1.